Das ist aus. Das ist schon wieder aus.
Okay, so we will start with the first talk now, which is Psychology of Security, a research program by Stefan Schumacher. So, please.
Good morning and welcome to my talk. My name is Stefan Schumacher. First, I would like to introduce myself. I'm the president of the Magdeburg Institute of Security Research, an institute we founded 2.5 years ago to do some security-related research in Magdeburg. I'm also the editor of an open access journal of security research, which is published on our website. As of today, we only have German language articles online, but we are also looking to get articles from English or articles in English, and we also are trying to produce proceedings for the DeepSec talks. So anyone who is giving a talk here at DeepSec is invited to submit a paper which we can publish in our journal. I've been a hacker for almost 20 years. I've also been a NetBSD developer for some time, but I studied educational science and psychology, and I did a lot of research on social engineering in the last years. And being focused on social engineering was also the reason for me to study educational science and psychology and not computer science or electrical engineering or something else. So my focus is, or my point of view to security is the point of view of a psychologist. And therefore we started a security research program in our institute, which is called Psychology of Security, because we want to do some fundamental research. We also want to do some research regarding organizational development and security. So how do organizations create a secure environment or create an environment where the workforce keeps security in mind? We are also doing minor research about cultural differences because trainings differs from country to country and from culture to culture. And my main focus is the didactics of security. How do we teach and train security? And the last point I will give an overview about is a knowledge base. It's a project where we try to create some kind of knowledge base for security-related knowledge. Yeah, first let me introduce why do I research security from a psychology point of view. First, psychology is an empirical and theoretical science. It describes, explains, and predicts human behavior and experiences. Psychology works about the human development and the internal and external causes and conditions of this human development. There are several parts or subjects in psychology. Most relevant here are differential and personality psychology, social psychology, which is actually doing a lot of research about social engineering, industrial psychology and organizational psychology, which is doing a lot of research about organizations and individual behavior in organizations and how do I find persons who fit into my organization. For example, if I'm looking for system administrators or security or workforce with security in mind. And of course, pedagogical psychology is also doing a lot of research on how to teach subjects. And I would like to focus on teaching security for users and end users. I have to define how I see security, as this is some kind of scientific talk. So my version of security or IT security is that security is a latent social construct and has to be treated as such. That means psychological and also sociological methods and tools are required. If the security of a system, and by system I do not only mean a computer system, I also mean a person or an organization, for example a company, if the security of a system should be enhanced, a diagnosis, prognosis and intervention is required. And doing diagnosis, prognosis and intervention is the core of psychology. This is what we do as psychologists each and every day. Security, or to explain what I mean with this definition, is security is concluded by making decisions. Individuals make decisions based on their biography, their situation, and how they perceive their environment. This is called constructivism or constructivistic approach. It's a school in psychology which was mostly developed in Austria and Germany by Heinz von Förster, Niklas Luhmann, Dirk Becker, but also influenced by a British mathematician called George Spencer Brown, who wrote some papers about how people perceive the world. Psychology is the science which researches these topics. If I want to speak about how people make decisions, I can only speak about this with psychological methods and tools. So if we want to do research about security, we have to use psychological methods, at least for this definition of security. So psychology is also, in my point of view, the only science able to research the basic fundamentals of security. When we are talking about security from a technical point of view, psychology can also be used to explain how we are talking in a technical view, what computer scientists are doing, what hackers are doing, what sysadmins are doing, what developers are doing or not doing. This can also, or every point of this, can be discussed using psychological methods. I have an example about this. It's an example from the 19th century here from Vienna. A physician named Ignaz Semmelweis, some of you might know his name, discovered that more pregnant women died in the Vienna General Hospital than in a monastery nearby. The monastery was run by nurses and nuns, and they had a lower fertility rate than the physicians, the trained and studied physicians in the General Hospital of Vienna. And he was doing research about why do the pregnant women in the General Hospital die more often than they die in the monastery, because it actually doesn't fit that nuns are better at treating people than physicians. And he discovered that physicians transmit pathogenic agents with their hands. And he proposed that physicians should wash their hands. The reaction by his fellow physicians was that his idea was rejected and he was considered to be crazy. There were famous physicians in Vienna calling him an idiot or calling him a liar, because they thought at this time that washing one's hands does not help when treating people. So physicians rejected the idea of washing their hands when going to the patients. Today, this seems silly, but in these days, the idea was new and it was rejected by the other fellow physicians. And this is a phenomenon which has been thoroughly researched in psychology, especially in organizational psychology and in social psychology, because this phenomenon still exists, even nowadays. If you bring in a new idea into an organization, people will reject this idea. And this is a huge problem when you're trying to evolve or to develop your organization, for example, into being a security-aware organization. So if you want to talk about this, we need psychology. There are also other examples. My favorite example, I wrote a paper on this, is the first flight of Ariane 5. It's the European rocket, which is usually started in French Guiana. And in 1996, the ESA switched from Ariane 4 to Ariane 5. And the first flight of Ariane 5 ended after 32 seconds with a huge explosion, which you can see here. And it costed only 320 million euro to send this rocket into nirvana and not into space. The problem has been, or the incident has been thoroughly researched, and the biggest problem was that the computer scientists who wrote the control program took the software from Ariane 4 to Ariane 5, but did not re-enable the test cases. There were test cases implemented to avoid that it comes to a buffer overflow, and they avoided that it comes into not buffer overflows, but into casting errors. There was if I remember correctly, an integer was casted into float or vice versa, and this led to an error in the computer of the Ariane 5. And the control computer thought that the Ariane lost its course and triggered the self-destruction mode. So the computer thought Ariane 5 is going down, and he triggered the explosion trigger to avoid larger damages, and therefore the rocket was destroyed by its own control program. And the problem was that the computer scientists who wrote this control program didn't enable the test cases. The test cases, or the disabling of the test cases in Ariane 4 was okay because Ariane 4 had a lower trajectory force and therefore didn't need the huge numbers required in this typecasting. And this was also documented in the manual, but the programmers who worked on Ariane 5 did not read the manual or ignored it, and they did not re-enable the test cases. And therefore, the whole accident could have been prevented if they only read the manual and followed the procedure described in the manual, but they did not, and therefore Ariane 5 exploded. This is a typical problem which psychology discusses. Ariane 5 is only one example, but there are more. Another example from computer science is buffer overflows. Like I already said, buffer overflows are still existing, and buffer overflows have been known at least since 1988, when Robert Tappan Morris wrote his first worm, the Tappan internet worm. He used buffer overflows. There is a paper on how buffer overflows work, has been published in 94 or 96, if I remember correctly, but still programmers are writing buffer overflows. So they are not aware that this problem exists, they ignore this problem, they are not trained as a programmer, maybe they are electrical engineers writing a control program, they never have had a computer science course or programming course, and they are still creating buffer overflows. And my favorite buffer overflows, for example, are in OpenBSD daemon and in Snort, which are security-aware programs. Other problems we usually face day-to-day in security is weak passwords chosen by users. You know, the Adobe hack currently, where a lot of weak passwords were used. Stratfor hack 2 years ago, where almost only weak passwords were used. Another problem is users are not interested in security. Whenever I go into an organization starting a security awareness campaign, most of the workforce considers me to be a threat to their work. They don't like me. Sometimes they even hate me, and they don't want to be bothered with security. Users don't understand how security works. They often say, I'm just a small worker, no one tries to attack my computer. Maybe they attack the managers or the CEOs, but not me, because I have no secret data here. They don't know that they are also part of the security of the organization. Admins do not patch their operating systems. Microsoft, for example, changed over the last years. They now have the patch day, and they provide patches usually very fast. But admins are too lazy or don't have time and are not aware that they have to patch their operating systems and apps. Some developers still use MD5 as a password hash. For example, Stratfor and Adobe, which is a huge no-go. And it has been standardized to use different hashes, which are harder to break. But people don't know about it, people don't activate them, so they still go with old and outdated software. And of course, social engineering and security awareness are fields which are almost exclusively researched by psychology and not by computer science, electrical engineering, or other engineering sciences. The research program I speak about has been introduced first last year here at DeepSec. I called it Vienna Program for Cyber Peace, because I did some talks and research about the cyber war debate. In my personal opinion, cyber war does not exist because we cannot wage war via the internet. 2 years ago, I tried to calm down the discussion a little bit and proposed to start discussing cyber peace and not cyber war. One part of this program, this Vienna program, is psychology of security, because it's my main focus on security and I want to do research there. We estimate that we need about 3 to 5 years for this program, and it started currently. We're still doing cooperations with some German research organizations and other organizations which we are discussing with to get fundings and money and support. So what do we need in this research program? We do need fundamental research about the perception of security. We do need fundamental research about personality and attitudes and security. We do need research about organizational development and security and cultural differences and security. Both points, organizational development and cultural differences, have been researched very thoroughly and with very huge research programs, but we have to check if these efforts can be transferred into security-aware organizations. Then we do need didactics, the teaching methodology of security. When we want to train users and teach users, we have to know how to train, what to train, and who to train, and what to teach. And this is what I'm going to talk about. So let's start with the fundamental research program, which is, of course, the fundamental part of every research program. So as I already said, we prefer the constructivistic approach, which means that each individual perceives the world in one's own way. So the way how you look at the world, there is a nice German word, Weltanschauung, which is also used as world outlook, if I remember correctly in English, is shaped by one's former experience. So every person sees the world in a different way. And we have to explore this worldview in depth by qualitative research. So we have to do research with randomized or random selected individuals. For example, We are using different tools and methods that already exist. We use qualitative, semi-structured interviews, which are led with different interviewees. There's an E missing. One interview which has been developed at our local university is called the autobiographic narrative interview, which we are currently doing with hackers, or people who identify themselves as hackers, and normal end users, which are of course also subject to our research. This interview tries to explain or tries to research how hackers shape their own personality, or how hackers are shaped. What differentiates the hacker from the user? What is the difference? Why is the hacker interested in IT and security? Why does he hacking? Why does he develop such a huge curiosity about technology? And why is the normal end user not interested in computers, in IT security, in cryptography, or what else? Then we are also doing so-called expert interviews with hackers and researchers, which means we are looking for experts in the field of security, which are usually hackers, system administrators, and researchers, and we try to research how they became experts and what differentiates the expert from the non-expert. And this is used at the base to decide how we can train experts. We need a formal way to train more security researchers, more security people. I don't want to call them hacker, but we have to train these persons, and we have to do this in a formal way. We have to develop a curriculum, we have to develop study courses, we have to develop material for schools, and this has to be funded, or is funded by this fundamental research. So the main question is, what shapes a hacker's mind? What shapes a user's mind, and how do they differ? How do users perceive IT security? Why are most users threatened by security awareness campaigns? They feel threatened by it. They feel threatened by IT security. How can this perception be changed? Now, this is a typical topic of psychology. There's a lot of research been done, and we try to transfer this fundamental research to our special topic of security. And then the main question I'm discussing is, are there science-based security awareness tools? There are a lot of security awareness campaigns, there are a lot of methods on doing security awareness training, security training, but most of them are naive in the sense of being not scientific. I don't say that they are bad, or it doesn't mean that they are bad by default, but they have not been checked with science, and I want to do this scientific research to do the scientific check of these methods and tools. One example I really like is the so-called risk homeostasis, a nice Greek word, which means actually how people behave in risky environment. And risk behavior is controlled by different variables in psychology. Variables which are interesting are, for example, the self-perception of an individual, the perception of its subjective skills, its objective skills, perception of risk, risk acceptance, and other variables. This is being researched in industrial psychology. It's a huge topic there, and it's done, for example, about air traffic controllers and pilots. Which person should be allowed to become an air traffic controller and which person should not be allowed to become an air traffic controller, because they tend to do risky behavior. You want, of course, an air traffic controller who does not accept a lot of risks, because you want them to do safe things or secure things. This also applies to workers in huge plants like nuclear power plants, motor vehicle operators, and such. There has been a great study done in the 1990s with East German taxi drivers. In East Germany, we used the Soviet-built Volga as a taxi. It's a car which is of the technological standards from the 1960s. There was no electronics on board, and it was built like a car from the 60s. And in the early 1990s, the East German taxi drivers switched over to Mercedes-Benz, which is the standard taxi in Germany. And the interesting findings were that the drivers using more modern cars had more accidents, because now they perceived their car as being superior, having more technology on board, and therefore they accepted more risky behavior, and they created more accidents. So this is one thing that is, in my opinion, very, very interesting, and this also applies to computer users. I've been an admin at our university for some years, and I worked in the Russian and English language department with people who have mostly no clue of computers and are usually not interested in computers. And especially the Russian colleagues were often afraid to surf in the Russian internet because they always thought the websites are very dangerous there. There is a lot of malware spread by Russian websites and such. And once I installed the new virus scanner we got from our university, from our computer lab, we got a campus license for Sophos Antivir, and I installed it on all computers, and then one of our Russian colleagues came up to me and said, wow, now I have a virus scanner, now I can go to all the bad websites from Russia, because now I have a virus scanner, now I am secure. Which is of course not the case. Just because you have a virus scanner doesn't mean that you are secure and can go to all the websites which are spreading malware and such. But this is how most people who are not into security perceive security. And this is a problem we have to discuss and research in psychology. And we can also of course use the research findings from other projects like this project here with taxi drivers. This also applies to people who drive a bicycle. If you wear a helmet on a bicycle, cars who are taking over usually leave less distance to you because they perceive you as being more secure by wearing a bicycle helmet. So this applies everyday living. Another thing that also influences security-aware behavior is personality. In psychology, we do have different theories how personality works. Most of you may have heard of psychoanalysis by Sigmund Freud with Ich, or the I and Über-Ich and S, and I don't know how it's called in English, but you know, Sigmund Freud and other stuff, C.G. Jung. We prefer to use empirical sound tools to examine personality traits and security-relevant behavior. The advantage of using personality for security research is that personality traits are, by definition, very stable over lifetime. So if I do an examination of a personality of a person who is 25 years old, we will find almost the same result if we redo it after 25 years when the person is 50 years old, because personality traits are stable. We are going to do a lot of quantitative research using surveys and such, and we try to reach as lot people or as most people as possible. And the #1 tool of choice for personality nowadays is the Big Five. It's a personality survey which uses 5 big factors. That's why it's called Big Five. And these factors are neuroticism, extraversion, openness, consciousness, and agreeableness. And we try to check how these factors influence security-relevant behavior. For example, are neurotic people more prone to risk or to insecure behavior? Are people with a high consciousness people who often change their passwords or choose stronger passwords or obey to security standards and rules? So we want to check if this has any influence of security-relevant behavior. This research is also done in industrial psychology because there is a huge discussion about person-organization fit. So how do I find the perfect person for a job I have to offer? Usually done in assessment centers and such. And we want to do or develop methods for checking if people fit on security relevant positions. Other things we want to research are the motives of persons, which are also very stable. Things like power, achievement orientation, and others, because they can be correlated with performance when doing jobs. And this has been done for general fundamental research, and we want to correlate this with security relevant jobs. So now let's go over to organizational view. In the first part, I spoke about fundamental research and how we want to do research with the individual in mind, but now I want to go to the organization. As you all know, security is a huge and hot topic in companies. A lot of companies are paying a lot of money for security awareness campaigns, for trainings, for tools, methods, and such. So lots of money is spent, and of course there are a lot of people offering awareness campaigns which are not scientifically based or which are just done by amateurs or not scientists or trained persons. A lot of different methods exist in when you want to do organizational development or organizational research. Some of these topics are knowledge management, leadership and training. Organizational development is an own research subject of its own. And we want to check which of them are useful for security relevant behavior. For example, what can we take from knowledge management or from leadership training to security? Because knowledge management has discussed how to spread knowledge and training in an organization. And of course, when doing a security awareness campaign, we also want to spread knowledge in an organization. It's just security knowledge we want to spread. So what parts of this research can be used? We don't have to reinvent the wheel every time. And we can use research which has been done earlier. One finding or one thing from my experience, not empirical sound, but from my experience as a social engineer and security awareness guy, is that strict hierarchies can easily be attacked with social engineering. So it might be useful or might be a good idea for some organizations to change their view of hierarchies and how they live by those hierarchies. Yeah, like I said, it's a very short part of our research program, as is cultural differences, but nonetheless it's necessary because the culture influences organizations and individuals. A company based in Germany has a different culture than a company based in India or in China or in the US or in France or in Brazil or Argentina. And this also has to be kept in mind. There is also a lot of research being done on this topic in the last 20, 30 years because companies now work and operate worldwide, and they often have cultural problems when they are huge companies. And we have to find those differences, and we have to find how they can influence security. For example, some countries prefer a more hierarchical approach in organizations. Other countries prefer a more relaxed, non-hierarchical approach. Another problem, formal problem, is how the training system is organized, the technical vocational education and training. In Germany, we do have a very elaborated TVET system, but this system is mostly unique to Germany and the German-speaking countries. So when I do research in the German TVET system, I cannot transfer it easily, for example, to France or Great Britain, because they do have a different system. They don't have the in-house training we do in Germany, and they don't have the vocational schools we have in Germany. They do their trainings in colleges or on the job. And this has to be discussed, and this has to be researched, and how these findings can be transferred to other countries and cultures. Lots of tools and methods already exist. There is also, cultural differences is also a topic where a lot of money can be made. There are cultural awareness trainings, and if you go from Germany to China to work together with Chinese people, you usually have to go through such a training, and therefore a lot of work already has been done, and we just have to find out which work can we transfer into our topics and can be transferred to our problems. So this is also a very small point of the whole research we are going to do. And then my favorite part, didactics of security. When writing about this, I usually ran into a lot of problems because influenced by our educational training system in Germany, we have a lot of research about didactics, but unfortunately it's very hard to describe and explain it in English, because the English training culture and the American training culture is very different from the German one, and this is the first problem I have with cultural differences explaining this. And didactics is a huge topic in German training for teachers and in German research, and it's not so big, for example, in the US or Great Britain. So I'll try to do my best to explain how we do it in Germany. Didactics is the science of learning and teaching. This is a definition we use in Germany. In English, you usually say teaching methodology, but didactics is more than just teaching methodology. We do a lot of research about this in Germany. We have done a lot of research in the last 30 years due to our dual TVET system. The trainees in Germany who are not going to university, only 20 to 25% of our pupils go to university. The rest goes into the TVET system, and they usually spend 2 days a week in a TVET school where they learn all the theories and backgrounds about their profession. And 3 days or 4 days of the week they go to their company where they're trained on the job and learn all the practical stuff. And therefore we do have a lot of research for the TVET teachers, those people who are training electrical engineers, nurses and such. It's very well funded and very empirical sound. A lot of research has been done, a lot of fundamental research has been done. And we have in Germany several IT-related professions and we have curriculums for this IT-related professions. And we are doing research about how to expand these curriculums for IT security. For example, some computer science related jobs exist, and we want to add IT security as one part of the training. So we can get IT security specialists trained in our TVET system, which is especially very interesting for the smaller companies in Germany, because small companies with 5, 6, 7 employees usually cannot afford to get a hacker or a studied computer scientist from university. So they can train their IT security specialists, their skilled labor on their own using this curriculum, so they don't have to develop it on their own. And this is one huge, or the biggest part of our research program is about how this curricula can be developed and how their training can be enhanced and enriched with IT security to get more IT skilled labor. The first question you have to discuss when you speak about didactics is, how can we teach security? How can I design lessons or trainings for IT security? Which methods work best under which circumstances? There are several ways to create lessons for school or trainings. You can use e-learning, blended learning. You can only let the pupils learn facts. You have to use, or you can use theory, you can use a practical approach. This is mostly relevant in our TVET system. You can read a lot about building a car, but you can also send the pupils out to a garage and let them build a car. And it makes a lot of difference which approach they are using. If you use the theoretical part only, they can tell you a lot of facts about cars, but they don't know how to assemble a car, how to build a car practically. On the other hand, if you only use the practical approach, they might be able to build this specific car, but when you go from, for example, Volkswagen to BMW, you might not be able to build the new BMW because you only trained on Volkswagen. And this is a huge problem. Therefore, we have the blended approach in Germany. We have the theory taught in schools and the practical approach taught in on-the-job training. For example, the culture of the TVET system is pretty relevant. For example, France is more theory-based. They do a lot of theoretical training in colleges, and therefore the whole training has to be done in a different way. We use the psychological model of competencies. When I speak about competencies, I mostly mean capabilities, psychological capabilities, the ability to do things, to get things done. And this model is used in Germany, and since the TVET system is governed by our governments, it's also in the state of a law. So actually, if you are a teacher in a TVET school, if you're doing training there, you are required to use this model. That's why I also stick with it. The idea behind this model is that you do not only teach facts, but you also teach how to do studying and how to research methods. So every trainee in our system has to learn how to learn on his own or her own. It's about independent learning. The trainees learn how to keep their knowledge up to date, because what you are learning in a TVET school outdates sometimes pretty much, especially in the technical professions. For example, if you're trained as a computer scientist in 1980, there has been a lot of development since 1980 to 2013, and if you never learned how to update your knowledge, you will sometimes only have obsolete and outdated knowledge, and this does not work well. So since 1996, all the curricula also emphasize independent learning, how to research methods, and how to keep their knowledge up to date on their own. They don't have to go to a training, they also have to learn how to keep or get the relevant new information on their own. And the trainees have to be able to decide what to learn on their own. And this is an approach I think is very great, because it enhances those people who have been trained in the system to keep their knowledge up to date, to know how to know what to learn and to know how to learn on their own. And this reduces the complexity in the system for the organizations and the schools, because you don't have to send them to a training every 3 to 5 years to update their knowledge and facts. So the main question is, how can we use this model of competencies or psychological capabilities? What are the best methods to develop these competencies? You can do action-oriented teaching, which is done mostly in our TVET schools where people are working in projects. When you're becoming a car mechatronic, you have to work on cars. You don't sit there and read a lot about cars, but you also have to work on cars, or you have to work on computer programs, you have to program your own projects and such. We also have the old concept of masterpieces still alive. So when you're finishing your training, you have to take a test, and this test is not a multiple choice test with a lot of theory questions, but it's usually a masterpiece. For example, the computer scientists have to create a program, a larger project, set up a server, create a database or something like that. The car mechatronics have to build a new motor or something like this. And this concept of the masterpiece allows you to test if the trainees are able to do real work. You don't test if they know a lot of theory, if they know a lot of facts. You test if they are able to work in the real world. And this is, in my opinion, a good and superior approach, because if we use this methodology, we know if they are able to work and to live in a real world. And we don't want them to be able to reproduce a lot of facts, because this is only teaching to leads to teaching to the test and theoretical teachings. The next question is, when speaking about didactic, is who has to learn about IT security? Of course, system administrators have to know a lot about IT security. Developers have to know a lot about security, but also end users have to know a lot about security. There has been a lot of, or I've been approached by some ministries in Germany if we could teach some courses about IT security or surveillance and privacy in some schools in Germany. But if I go to a school and teach about Prism and Tempora for one day, the teachers there cannot do their normal curriculum. So I have to find reasons why the school should spend one day of time on my program. And of course, if I go to a company, I also have to make clear why the company should pay me to do a security awareness training. And if I'm doing a security awareness training, they are not only paying me, but when I'm training the end users are not doing their work. So it costs a lot of money to do a security awareness training for companies, and we have to find reasons and make clear why this matters for companies, for schools, for universities and other organizations. And I think the best approach is to create different roles and then determine what each role has to learn. Of course, the end user does not have to know everything a system administrator has to know. It does not make sense to teach elliptic curve cryptography to a normal end user. They just have to know what a secure and strong password is, and let the system administrators decide which algorithms and working modes to use. So this leads to the next and last questions about didactics. What to teach and what to learn. Who needs to understand elliptic curve cryptography? Webmaster, system administrators, end users, developers. We have to find some kind of roles, and we have to create a curriculum, a list of what to know for each role. And this has to be a practical approach which works in the real world, and it has to be an approach which works for almost every end user in every organization. So if you have a car mechanic working for Volkswagen, he has to have the same training as an office clerk working for Siemens or BMW or another company. So the main question is, who needs to understand what? And the next questions when we ask who needs to understand what is, how do we test what he knows? So if we are doing a teaching, we usually have to do some kind of test in the end, because we want to know that the trainees understood what we try to teach them. And therefore we have to develop testing methods. And as I said, I prefer action-oriented teaching, which means they are doing project work. So we also have to find standards on how to test if the project failed or if the project worked. And this can be very, very difficult, especially when doing IT projects or security-related projects. So this is a lot of work that has to be done. And the last question is about when and how do those curriculums and tests need to be revised? Can we create a curriculum which works for the next 20, 30, 40, 50 years? Or do we have to create curricula or curriculums which only work for the next 5 years? Because maybe in 5 years elliptic curve cryptography is outdated and we have to teach a different thing. Or quantum cryptography and quantum computers are there and have to be included in this curriculum. And normal cryptography is outdated, or whatever else might happen. So keeping those curriculums up to date is a huge approach. Usually every 15 years, some of the professions in Germany are revised. For example, in 1996, the car mechanic was dropped and was changed into car mechatronics. So the people who are now trained to repair cars also integrate computer science or parts of computer science. They learn about IT because modern cars have a lot of computers in it. So they learn how to use their laptops and diagnostic programs made by Bosch on how to diagnose a motor. And in the last 50, 60 years, car mechanic was a very low profile job. It was not that complicated, but now the curriculums have changed, and car mechatronic is a very, very, very high technical, very skilled training, because they have to learn about computer networks, they have to learn about IT, they have to use computers to do diagnostics. And every, I think, 10 to 15 years, we also have to revise this curriculums to include the new things which evolved over time. We are currently developing a web-based teaching for some organizations in Germany. It's part of the program, and we try to use our modularized curriculum adapted for different roles. We are cooperating with some police organizations in Germany, and we are developing a web-based training for the police officers so they can learn about IT when doing their work. And this also includes mobile learning methods. So they can use their smartphone, iPhone, tablet, and learn a small lesson of 20, 30 minutes when they are commuting to work. And this is also an interesting approach because it enables them to learn when they have time to learn. They don't have to sit down on Monday at 9 o'clock in their office to start a webinar, but they can learn on their own using their own devices when they are traveling to work or sitting there and having a break or something like that. And we also include tests and certification, which are of course also web-based, and therefore we have to find some different approaches for those tests and for the contents of what we are teaching. So the last part I want to speak about is a knowledge base. One problem I've found in the last 20 years being a hacker is that too much information is floating around, especially regarding security, the configuration of computer programs and such. There is also too old information floating around. This information is obsolete and outdated. There is false information floating around. And I speak of, I think of compiler options. I think of how to configure your NetBSD server, how to configure this trace using OpenBSD, which cryptographic algorithm should you use when you create a new PGP key and such. And it's very hard for new users or people who are not that deep into the topic to identify the correct knowledge. It's very hard to check if the information given to you is correct or not, if it's outdated, if it's wrong. And we could try to create some kind of central knowledge base where central standards are created. For example, there is a standard floating around on how to implement password hashes. It says don't use MD5, SHA1 and others. Use different standards, but most people don't know that this standard exists and most people don't use it. Another problem is who decides about the contents. Usually when speaking or when new curriculums are created, experts meet, people from the companies, teachers, scientists meet, and they do some kind of roundtable discussion on updating the new curriculum. And if we want to do this, we also have to create some kind of roundtable of security experts who are interested in creating such a knowledge base, which we can then use as a base for developing the curriculum. A better approach or a required approach is to empower the users to identify correct and required knowledge, to enable them to say this information is bullshit, I cannot rely on this information, I have to use different methods. And this is also one point of our research program. Yeah, what do we have to do? We have to finish the fundamental research. Unfortunately, fundamental research, especially qualitative research, takes a lot of time and resources because you have to transcribe the interviews. You have to do the hermeneutic circle of interviews, you have to interpret it, you have to condense the data. We have to discuss what to teach. This is something I mostly want to discuss with hackers, security experts. This is not a psychological topic on its own, it's a topic for all who are into security and who want to discuss this topic. We have to do research on cultural differences and find adequate or the proper teaching methods for teaching IT security relevant things. And this is already my last slide. If you want to contact me, feel free. This is our website. my email address. You can contact me in English or German. We also have a channel on YouTube for those who speak German. There are mostly German talks we have online. I also have some talks about this research project already online, but they are all all are in German. We also have some of the older DeepSec videos there if you're looking for older talks. Our journal can be found at this address. Like I already said, current papers are only in German, but we are working on getting the first English articles, and if you are interested in publishing anything about security, contact me. We are an open access journal, so it gets online, it's citable, it's reviewed, and it's a scientific journal. Yeah, if you want to, if you have a smartphone, you can use this QR code. It's my business card, and all the contact data is given there. And I can tell you it's free of malware, so I don't hack your smartphone with this QR code. So do we now have time for questions, or?
We are unfortunately a bit late, but there's 2 or 3 questions shouldn't be a problem as we have the coffee break now.
I'm here for the next 2 days, so we can discuss.
So, any questions? Okay, so thank you.
Thanks.